Okay everyone, I posted some information to the Discord site, and what I've done is I've given some instructions on how to hook up the double op amp. Carlos did some digging for us on the internet this morning and found this data sheet. I was able to use it in order to hook up a double-ended power supply, and you'll want to do this on your MyDAQs because you're going to get better control over your voltage and your setups. I'll show you in a second what my board looks like, but I wanted to scroll and just show you a couple of things here in the program. First of all, I put some more detailed instructions on here on how to go about doing this. The data sheet that you want, link is right here. But basically what we're doing here is you can go to your book, or you can go out to the internet. We're creating two voltage follower circuits, and I think I got that over here. Okay, it's on page 2-13 of your lab book, but it's a really simple circuit, and what you do is you get out what you put in. We want to do this because we're going to get better control of our circuit, and we're going to get more current, I think, from your MyDAQs by doing it this way. So let's just take a look at how I've wired up the board. Here on the bottom of my MyDAQ breadboard, where it's going to be out of the way as much as possible, I put my op amp, and my divot or my notch is pointing up. So I have pin 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now this pin right here is your V minus for your chip, and this upper right hand corner is your V plus. So you can see I've got a red lead kind of tucked around between the battery and the board channel here, and I've got it going up to plus 15. And then I've got a blue wire down here to pin 4, VCC minus, or VC minus, or V minus, excuse me. Okay. Then on the voltage follower circuit, you saw that we were feeding back the output to the input. So here pin 1 is my output, and pin 2 is my negative, or my inverting input. Okay. And here I've done the same thing over here for op amp B. I've got my output and my input jumpered. Okay. Now, what else have I done? Here's a gray wire going to my non-inverting input for my B op amp, and here's a black wire going to my pin 3 non-inverting input. There's two op amps in here, and we're taking advantage of both of them. So here is all your A pins. Here is all your B pins, and then the voltage plus and the voltage minus for the device is shared here. Okay. Now, I've also on my board, I've gone ahead and I've put output for op amp A to blue, and output for op amp B I've jumpered to positive. Why have I done that? Well, when we're doing our experiments going forward, we're going to treat this thing just like our battery, just like our power supply. Blue being our negative side of our battery, this red jumper right here going to my red bus. And then if we look up at the top, I've jumpered my red together and my blue together. That may not always be advantageous for every project that we're working on, so we can always grab these and remove them if we want to do something separate over here and over here. But this gives me ready access to the power out on my op amp. Okay. So my analog in 0 here, and my analog in on my gray wire 1 go back to here, my analog 0 and my analog 1. Okay, now I want to test to see that this thing works, and I know that my light emitting diodes take 2 volts. Okay, so I'm going to drive my analog out through my voltage follower, and I know I don't get any fancy signal out, I just get out what I put in for the follower, so it makes it a nice easy circuit to test to make sure that all my setup is working correctly. Alright, over here on my computer I've emailed you guys something called the set AO voltage, and you can see I have 2 independent sliders, AO0 and AO1. Now what I can do here with this is I can go ahead and I can turn my power on, my green light, on and off. I can stop my VI if I want to, and I can also click run again up at the top. My run button will make it run, okay? And I'm just going to grab this slider. So now I should have the ability to get positive 10 volts or negative 10 volts from either channel independently. So I want to test that. And what I'm going to do is I'm going to go over here and I'm going to wire up an independent circuit on the, we'll call it a second stage, but we're always going to leave this power circuit in play now because I know that I can tap into either rail and get plus or minus volts with respect to my analog ground. So I've created a ground side to my circuit. I've put a green and a red LED in parallel with each other, and then I've taken a 470 ohm resistor and I put that in series, so I have a series parallel circuit. And then I take a wire and I'm just going to test out my AO0, which remember I have AO0 going to my blue rail here. Alright, so when I go ahead and I move my slider above 2 volts, magically my LED starts to come on, and the more voltage that I give it, the more current that goes through the circuit. And so I just slid my slider all the way up to 10 volts, and I'm sliding down. As I slide down, I get less and less current until I drop below 2 volts when it shuts off. Okay, and that would be expected. Now when I drop it down to 0 and I go below -2, my red LED starts to come on. I've put both of these in parallel, but I put my green LED in forward bias and my red LED in reverse bias. And I can see it getting brighter and brighter the closer that I get to -10. So I know that my channel A is working. Everything on channel A is good. Okay? So I've gone ahead and I've hooked up A output, the inverting and the non-inverting inputs, voltage -15 volts, voltage +15 volts. Now I've got my B's that I hooked up as well. Okay? So I should have my output, my input inverting, and my input non-inverting set up over here as well. So let's take a look. So here's how this is wired up. Now I've got my output to my red bus bar. I've got my red bus bars connected, so I could just go like this and I should be able to see that I get power out of my LEDs the same way. So first I'm going to go high to 10 volts positive. I'm going to start to drag this back down. Bear with me, I'm not left-handed. Below 2 volts, it shuts off. Now I'm approaching -2 volts. Start to see the red come on. More. And then I'm going to go back down 6, -4, -2, and back to 0. Okay? So I basically have set up the ability for myself to have a 20 volt supply. Okay, and that's the last point here, is that I'm using this in respect to ground right now, but I should be able to take and go across my rails like that. And now the way I have this set up, I'm going to want a more negative voltage here and a more positive voltage here. So I'm just going to go ahead and I'm going to test it. Okay. And there we can see that I'm getting on one channel. If I slip this back and forth, and I'll reset that one to 0. And now I'm on channel 1. I go positive, I get green. I go negative, I get red. When I'm on AO0, I go positive, I get red. I go negative, I get green. So, by using my green and my red rails across my op amp, I can get a differential. I've got a differential of 10. Now I should have a differential of 20. Alright, that's enough for this tutorial. I'll add some more stuff as we go along and try to give you more of how we get the amp, excuse me, more of how we get the MyDAQ working.